Well, now you know about what hash is, what encryption is, what are the differences between those two, what password-based key derivation 2 is, what HMAC is, how PBKDF2 is used in conjunction with WPA2. We are going to go in some practicals, and those practicals will actually show you what I told you about rainbow tables, brute force attacks, how to make a hash, etc. So I have already told you the brute force attacks, how you can take your word list and create hashes of each of them to match a stolen hash, or you can use the same for PBKDF2 and also in PBKDF2 with WPA2. So I will be showing you all of these in practicals with some codes that I have written in Python, and these are very small pieces of code. I have also made a list of passwords, basically not passwords, I have just used whatever words came into my head in the time. So anyways, I'm going to use this list of my passwords so I can use those passwords as a word list when I'm doing my brute force attacks or creating my rainbow tables. Alright, so let's go to the first program that I want to show you is how to make a hash. So as you can see, I have imported the module called crypto, which comes with Python 2. You have to just install it. So I have imported the classes password-based key derivation function 2. I have imported random, but I have not used it because in WPA2 the salt is not randomly generated, but the SSID is the salt, and I have imported the SHA-1 class from the same module so I can make some SHA-1 hashes. So this is the part where I create a SHA-1 hash. So let's think of a word, maybe a complex one, why not? So let's take a complex word, maybe @hacker 66789, whatever I want to use. So I have to just copy this password and copy and paste it in my word list so I can show you the brute force attacks. Anyways, I just saved it right now, and let's go to the hasher program. So I will now run the program. So as you can see, the program is finished within a 0.3 seconds, and I have got the hash. Now let's copy the hash. Alright, let's copy the hash and give it to my brute force program. Alright, so this is my brute force program. I have used the same modules and the same classes. The only difference is I'm going to run a loop where I take all the words from my word list, make a hash, a SHA-1 hash, each time a word is taken in, and I will just compare if the word from the word list matches with the word which is going to be the hash which I just made from the word which is going to be this one. Alright, the hash for this password is taken in as the variable word, and this word is compared on each loop where I create a hash, a SHA-1 hash of each of the words in my word list, and I just compare both. If a match has occurred, I just did break, and I'm going to print the current word that has been looped. So let's try. I have just copy pasted the current hash, and the password is in my word list in the last entry, as all you have already known. So let me just run run this program. You can see that the password is being brute forced. It took exactly 0.3 seconds, astonishingly. Anyways, I just got the password. This is basically brute force. If I just take another example here to show you what happens in each loop, let me just do that. So I will just do, so print I, then print word. Alright, so now let's run the program. Now you can see for each of the entries, for example, however was the original word, and this is the same hash. Then Sony is the original word, and this is the exact same hash. This hash represents this one, and if you even want to see a better version, that what is the hash for each of those words, I would have just to print HW. Alright, so print HW. If I run the program, you can see manually here from the very first entry, the original word was however, the hash SHA-1 for the word however was this, and the original, the stolen hash is this one, right? So does this two match? No. So it proceeds to the second loop. Now Sony is the word. Now this is the hash SHA-1 hash for Sony, and this is the stolen hash. As you can see, all of the entries, if I just double click it, all of the entries have the same password, because this is in fact the stolen password, and these are the hashes for each of the words in the brute in the list, right? So the hash for the SHA-1 hash for Sony is this one, and does both of these match? No. So next word in the list, does both of these match? No. So until and unless all of them matched, the program ran its loops consecutively. So when the password hacker0r6677984 came in, the hash, the SHA-1 hash for hacker for this password is this one, and the original stolen hash is this one. So does both of these match? Yes. So the program breaks here and it gives me the original password. So this is a basic brute force attack. Now before showing you the PBKDF2 version, I will just use something, as I said, the rainbow tables, right? So for the rainbow table I made this program. So if you see what I did, I open up my word list, then for each words in the word list I make a SHA-1 hash and then append those hashes into a file, right, which is rainbow.txt. The W here means write. So on each iteration, a SHA-1 hash of each of the words in my word list is going to be converted to SHA-1, and then it will be written on a file called rainbow.txt. So let's just run it and see what happens. As usual, finished in 0.3 seconds. If I just go to my folder here, you can see a file called rainbow.txt, which was not present there earlier, right? So if I just hit enter, you can see all of the hashes just lying there. You can see that with naked eyes. So now if I run a comparison for the copied hash, for example, this one was the hash, right? Now what you can do, okay, not this one, yes, this one was the hash, right? So if I just copy it right there, go to my rainbow.txt and just click on find, hit enter, you can see that this was in fact the password. Alright, so this is basically what is called a rainbow table. Now let's go to the main thing, which is PBKDF2, where I show you the exact same thing, what happens in a Wi-Fi router. So let's just comment this out for now, and let's enable this. So let's take the word, okay, I will just use my own Wi-Fi router's password, alright, which is surprisingly James Bond 007, which is a very bad password. Do not use that. I just use that in my guest network. So the salt for my SSID is deceiver. The derived key length for all of the Wi-Fi routers or all WPA2 is 32 bytes or 256 bits. So I'm just going to give 32 bytes, and number of iterations is 4096. You remember from the theory, right? Now let's run this program. Yes, I got the hash, and it's also 0.3 seconds, but believe me, this is only because I have a fast computer, and 4096 is not a right iteration number for nowadays, because even the worst program that uses PBKDF2 at least uses 10,000 iterations. So if I just make it 10,000 and run, just okay, you can see that it took 0.4 seconds. But again, this is not a very safe practice. But in case of WPA2, you can actually see when I run it on Kali Linux, it takes the same 0.3 seconds of time. So anyways, if I just go, iterations is 4096 for the default for all WPA2. I get, sorry, yeah, what happened again? Yeah, sorry, I get this hash, right? So let's copy it and go to the program where I brute force a PBKDF2 password. So also Aircrack has the same thing, because Aircrack also knows that Wi-Fi uses the iterations as 4096 and the salt as in the SSID or service identifiers. So let's copy and paste the password or the hash here. Now I will just, the SSID was I guess in the D was in camel case. I don't know, let me just see. Yes, the deceiver, the SSID starts with a small d, so I will not also change that here. Okay, I used a camel case d here, so let's use a smaller d. Copy and paste. You can see the length of the output value is exactly same, but even just changing the camel case of a letter changes the whole hash completely. This is the property of hash which I have already mentioned, right? So this is the word, the decay length is 32 again, the iterations is 4096, and I am going to take every word from here which is in the word list and run the program. So let's run it. Let's see how much time it takes. See, it just took 0.4 seconds when I'm even taking so much words from the word list. Anyways, you can see the idea from this. What am I trying to do, right? So now you have learned the practicals about how hashing is done, how a PBKDF2 password is created by your Wi-Fi router, then how to brute force a PBKDF2 password. I have also showed you how you can manually see what happens in each loop of a brute force attack and how to generate a rainbow table, right? So now you know all of this. So let's move on to the next tutorial.